Hi, welcome everyone. My name is Peter Pajkossy, and my field of inquiry is cognitive science. This field investigates how information processed by your brain leads to responses, communication, and any output, actually. And crucially, cognitive scientists think that during this process, there are important cognitive processes like memory, attention, and perception, which modulate this process. And people at my department are dealing with this interaction of these processes and how they lead to goal-directed behavior and pathology. And a newly formed research group, which I am the PI, investigates specifically the interaction between attention and memory. And I would like to speak a bit about our research interests and our methodology. Regarding methodology, we use eye tracking, which is a popular and well-known method. And it basically uses infrared illumination to find the center of the pupil and use this to infer where the participant is looking. And eye trackers can be used in laboratory settings and also in everyday settings, like for example during driving or shopping in a shop. And what can we measure? First, we can measure several parameters of eye movements, for example, duration of fixations and saccades, and where participants are looking and how long are they looking there. And we have other method which we are very often use. This is pupillometry, and this is basically the measurement of the diameter of the pupil. This is a less known method, but actually every eye tracker can do it because they identify the center of the pupil for gaze detection. But it's not optimal for pupil detection, and you don't need actually an eye tracker to measure the size of the pupil. So we are actually developing an easy to use open source pupillometer for our measures. And pupillometry is first and foremost the size of the pupil is sensitive to luminance, but we are more interested in mental effort. It is linked to level of mental effort, the pupil dilation, and also it is linked to the activity of important neural networks, which are related to attention and memory. So we are using this methodology extensively, first to investigate attention through fixation patterns. For example, we could show that fixation patterns are a reliable marker of implicit learning and attentional set shifting. And using pupil dilation, we could also show that the magnitude of pupil dilation during retrieving information which was previously learned is actually associated with the quality of these memories, the strength of the memory, how well practiced it is. And even we could show that pupil dilation is sensitive to previous encounter with a stimuli without a direct memory test. And finally, we also have data on the link between brain processes related to pupil size and the processing of uncertainty, surprise, and change in the environment. For example, we could show that during simple story listening of narrative stories, the pupil delays shortly when there is a significant change in the story, a narrative switch, for example, a new protagonist or a new location is introduced. So to sum up, pupil size and gaze location, gaze behavior are important measures of attention memory, and they might signal pathology in several psychiatric and neurological diseases. So our main plan and also our main offer for potential cooperation is how we can use this technology in the early diagnosis and detection of these diseases. But our results regarding the link between memory strength and pupil dilation make it also possible to use this technology in educational settings. And of course, this technology and our knowledge might be important or interesting for any application where the online processing and online measurement of human attention is important. And the question mark is there to signalize that we are also open to any other kind of cooperation. Thanks for your attention.